We all feel like we know who we are, this self that's built on a whole lifetime of experiences. But what if I told you that foundation is way more fragile than you think? What if the very story of you is being quietly rewritten every single night by a process you can't even see, let alone control?
It all starts with this one kind of unsettling fact. Every night, while you're asleep, your brain is doing a secret cleanup. It's actively deleting parts of your past. And here's the thing, this isn't some kind of mistake. It isn't a bug in the system. It's a feature.
And just to be crystal clear, we're not talking about forgetting your dreams. No, this is about real waking life memories. Things you actually did, people you met, conversations you had, things you learned, gone, deliberately erased.
So, what's actually going on here? Well, the scientific name for it is synaptic pruning. For a long, long time, scientists thought this was something that only happened when we were kids, as our brains were growing. But a recent discovery from MIT in 2023 confirmed it happens to adults too, every night. Your brain is basically like a gardener, trimming away the connections it thinks are unnecessary. And here's the key part. It decides what isn't worth keeping, not you.
Okay, so that idea alone is pretty wild, right? But it leads to an even more disturbing question. If the hardware inside your head can actively delete parts of your past, what's to stop it from writing new ones? From creating memories of things that never, ever happened?
And this is where we have to talk about the incredible work of psychologist Elizabeth Loftus. For over 40 years, she has basically torn apart this popular idea that our memory works like a video camera. She proved it's not a playback device at all. It's more like a reconstruction engine. Every single time you remember something, you're actually rebuilding it from little fragments. And, well, every time you rebuild it, things can change.
And just how easily can things change? Well, in her famous Lost in the Mall study, Loftus managed to convince people they had this really vivid memory of being lost in a shopping mall as a kid. The thing is, it never happened. It was a complete fabrication. And the result? A whopping 29% of people didn't just believe it. They started adding their own details to this completely false memory.
As Loftus herself puts it, memory is malleable. You don't just hit record and then play it back. It's so much more complicated, and honestly, so much more vulnerable than that. What this really means is that just because you remember something with 100% confidence, with all the details and all the emotion, that doesn't actually guarantee it's true.
So, okay, our memory software is buggy. It's open to being manipulated. But the story gets even weirder. Sometimes the hardware, the actual biological wiring of our brains, has these failure points built right into our genes by design.
Let's start with something that scientists have started calling the reality trap. It turns out a single gene mutation can literally stop a brain from updating its beliefs. It can get locked into an old, outdated version of reality. Just look at the difference here. A typical brain is in this constant dance, right? It's balancing what it thinks is true with all the new information coming in from your eyes and ears. It adapts. But with a mutation in this one gene, GRIN2A, that whole process breaks down. The brain starts to value its old beliefs so much that it just ignores new evidence that contradicts them. It gets stuck, completely detached from what's actually happening right in front of it.
And this idea of our biology being, well, kind of pre-programmed, it doesn't stop there. Our genes also have these ticking clocks inside them, mechanisms that are basically designed to decay over time, pushing our minds to decline in two very different but equally fascinating ways.
First, you've got what you could call the shriveling mind. Researchers at UC San Francisco found this protein called FTL1, and as we get older, our brains get flooded with it. The effect is, well, it's not good. FTL1 basically puts the brakes on our neurons. They stop making all those complex branch-like connections that we need for learning and memory. Instead, they just shrink.
But get this, and this is the incredible part. It's not a one-way street. When those same researchers lowered the FTL1 levels in old mice, their neurons started rebuilding those lost connections. The mice actually got better at memory tests. The lead researcher said, "It is truly a reversal," which suggests that maybe, just maybe, some parts of aging aren't permanent damage, but a state that can actually be reversed. Now, the second biological clock is much more precise and much more sinister. It's basically a DNA death clock. In a condition like Huntington's disease, there's a specific DNA sequence in one gene that just slowly expands year after year over a person's entire life. For decades, it does absolutely nothing. This model here really shows you what's happening. A neuron can spend more than 95% of its entire life in this completely harmless phase. It works perfectly. But underneath the surface, that little bit of DNA is quietly growing, ticking towards a critical point. And this is that point. Once that sequence expands past a certain number, about 150 repeats, the gene suddenly flips. It becomes lethally toxic. The neuron's entire identity gets scrambled, and within months, it dies. It's a biological countdown that was programmed from birth to end in self-destruction.
Okay, so after hearing about nightly memory wipes, fake realities, and genetic time bombs, it's pretty easy to feel like we're just passengers, right? Like we have no control. But science also shows that we're not totally at the mercy of our biology. We can influence the system. So the real question is, can you actually have a say in what your brain decides to keep? And the answer is yes, you can. Here are 3 simple science-backed techniques. First up, the 20-minute rule. After you learn something important, just rest. Give your brain a 20-minute break. No phones, no new information. This gives the part of your brain locking in the memory, the hippocampus, a protected window to do its job. Second, emotional tagging. Your brain doesn't really care about dry facts, it cares about feelings. So if you want to remember something, connect it to a strong emotion. The stronger the feeling, the stickier the memory. And finally, the consolidation window. Your brain strengthens memories while you sleep, so try to get some sleep within about 6 hours of learning something new. That's the sweet spot. Now, these tricks can help you steer your memory, but they also bring us right back to the central philosophical question of all this. If your past isn't some stable, concrete record, if it's really just a fluid document that's constantly being edited, deleted, and rewritten, then what does that say about you? Who exactly are you? Here's the bottom line. Your identity, who you think you are, it isn't based on an accurate recording of your life. You aren't the person you remember being. You are the person your brain, through all its nightly pruning, its constant reconstructions, and its deep biological programming, has decided to let you become. You are a living story, edited daily. And the biggest question of all is, who's the editor?